Last time we built a diode, a one-way valve for current. Useful, but dumb. It only ever does one thing. Add one more layer of silicon and you get a valve you can control. A tiny current at one terminal decides whether a much larger current gets through. That's the transistor. It's the reason you have a computer. And today we're going to put a number on it. The diode had two terminals and one p-n junction. The transistor has three terminals and two junctions, back to back. The three are called the emitter, the base, and the collector. Base in the middle. And the whole trick lives in that middle layer. Take the N-type and P-type silicon from last time and stack them. N, P, N. That's an NPN transistor. The outer N layers are the emitter and the collector. The P layer between them is the base. Here's the key. That base layer is made extremely thin and only lightly doped. So when carriers come charging in from the emitter, almost none of them find a hole to fill. They shoot straight through into the collector. Let's turn it on. Forward bias the base emitter junction. Same as any diode, you need about 0.7 volts. That opens the gate. Electrons pour out of the emitter into the thin base. A few get captured, and that becomes the base current. But because the base is so thin, the vast majority sails straight on through to the collector. And that's the whole idea. A small base current controls a large collector current. Turn the base off and everything stops, which gives us our number. It's called beta, the DC current gain, and it's simply the ratio of those two currents. Beta equals collector current divided by base current. A typical small transistor has a beta around 100. Rearrange it two ways and you have everything you need. Collector current equals beta times base current, and base current equals collector current divided by beta. One more, and it's just Kirchhoff's current law from episode 17. Whatever goes in must come out. Emitter current equals collector current plus base current. Let's use it. A transistor with a beta of 100, and we feed the base 0.1 milliamps. Collector current equals beta times base current. 100 times 0.1 is 10 milliamps, and the emitter carries both. 10 plus 0.1 is 10.1 milliamps. A tenth of a milliamp, just controlled now, the one you'll actually build. You want to switch a relay that draws 200 milliamps using a 5 volt signal from a microcontroller. First, how much base current do you need? Base current equals collector current divided by beta. 200 divided by 100 is 2 milliamps. Now size the resistor. Your 5 volts has to cross the base emitter junction first, and that eats 0.7 volts. So 4.3 volts is left to cross the resistor. Ohm's law. 4.3 volts divided by 2 milliamps is 2,150 ohms. Round to a standard 2200 ohm resistor. In a real switch, you'd go smaller to drive it harder, but that's your starting point. So, 3 layers, a very thin base, and a small base current that commands a big collector current. Beta is the ratio. Collector equals beta times base, and the emitter carries the sum. next time. Back to the board, grab a pencil, and I'll see you there.